Connecting maths and science, a cross-curricular approach. Primarily, we must consider the definition of the words cross-curricular. Cross-curricular teaching can be defined in a number of ways. A basic definition can be derived from Barnes, who describes cross-curricular teaching as when the knowledge, skills, and attitudes of a number of different disciplines are applied to a single experience. The merits of a cross-curricular approach have been outlined in a number of reports, including the Haydo Report of 1931 and the Plowden Report of 1967. The assertion from the Plowden Report is that children's learning does not fit into neat subject categories, suggesting that a cross-curricular approach could be inevitable. Barnes extends the reasoning outlined by Plowden and Haydo. Barnes comments that everything which surrounds us in the physical world can be seen and understood from multiple perspectives. He argues that everything in the world is cross-curricular. In 2009, Jim Rose submitted a review of the primary curriculum to the government. In his review, Rose concluded that cross-curricular studies strengthen the learning of subjects which make up its content. Rose states that from the standpoint of young learners, making links between subjects enriches learning. The NCTM have furthered this view. They state their research demonstrates that an integrated curriculum provides endless opportunities for a more relevant, less fragmented, and more stimulating experience for learners. Fragmented learning experiences have been noted frequently in academic research, such as Sheila Hendry's report, Mathematics Enhancing Science. Henry found that children are struggling to make sense of certain subjects when asked to apply a specific set of skills. Further to this, Cohen 1995 states that brain research supports the idea of thematic teaching. Cohen comments that people can comprehend subjects such as maths and science more easily through patterns and connections than fragmented pieces. Children growing up in a world that is ever-changing, with the ability to apply different skills and knowledge to any life event, has become an important quality to progress. We may ask, is a cross-curricular approach the best way forward, or should we stick to the discrete method of teaching? Integrating maths and science in the curriculum can have a number of benefits. Research conducted by Donna Berlin, entitled A Longitudinal Look at the Attitudes and Perceptions of Integration of Maths and Science, outlines key benefits a cross-curricular approach to learning could have in a primary school setting. Berlin states, it can provide coherence so that student experiences add up to more than a collection of miscellaneous topics. This would allow children to form a more holistic knowledge of what they have been learning. Berlin states that connecting maths and science through the curriculum can provide interconnected knowledge so that children can make logical and natural connections in both real and man-made worlds. Research conducted by Morrison and McDuffie furthers the thoughts of Berlin. They state that in their research connecting science and maths, that cross-curricular links between mathematics and science meant achievement levels were higher, and that an integrated approach allowed children to have freedom and ownership of their work. Government bodies such as Ofsted and QCA have also got behind the idea of cross-curricular teaching. Ofsted stated in their 2002 report that cross-curricular teaching was a feature of a successful primary school. This suggests there can be visible benefits of cross-curricular teaching. It is interesting to note that not everyone views cross-curricular learning as the most effective teaching discipline. Some favour the more traditional discrete teaching. Discrete teaching basically means teaching one subject at a time that is isolated from other subjects. In the report, Potential Benefits and Barriers to Integration, written by Cobbs and Nicol, pros and cons of a cross-curricular approach versus the discrete approach have been considered. One of the main concerns this report outlined were that by connecting maths and science in a cross-curricular way, it may trivialise lesson content, and that in the need to find a similarity between the two subjects, vital gaps in learning could be created. Considering assessment, it could appear that a discrete approach may provide an easier method to assess. In this report, Cobbs and Nicol argue that most standardised tests were designed to measure ability to perform routine processes with disciplines rather than across disciplines. This could prove problematic for cross-curricular links, where finding a suitable means of testing may be difficult. The NCTM have also argued that maths and science often employ similar vocabulary with a far different meaning attached to such. This could create further problems for teachers. It has been argued that teachers are lacking in content and pedagogical knowledge to teach two disciplines with a cross-curricular approach. This presents another organisational problem. If teachers do require pedagogical support, finding time or days within the school year to provide this support or training could be difficult, as often schools' yearly timetable is already full. Time constraints, scheduling of students, and planning also appear to be a problem in the finding of cobs and nickel. With pros and cons to both methods of teaching, we may ask, what are current teachers' perspectives on establishing cross-curricular links? Research carried out by the NCTM stated that teachers value the integration of maths and science and recognise student benefits. However, teachers did express their concerns in research undertaken by Donna Berlin. They stated that they needed more experience and knowledge to teach cross-curricular subjects. The teachers also expressed concerns over planning time, which could be longer if teaching in a cross-curricular way. Now we have considered teachers' view of cross-curricular teaching, it is important to consider the links, if any, that science and maths already have. The links between science and maths exist without some of us even contemplating them. Taking a general view towards both subjects, it becomes apparent that they both employ similar or even identical disciplines. The 2014 National Curriculum highlights direct links between the two subjects, which include measures, interpreting data, and drawing conclusions from statistics and graphs. The NCTM reports supports these direct links. They have stated that research has shown that standards in both maths and science closely correlate, and that this correlation is sufficient to imply that students learn both mathematics and science through similar processes. Maths and science can be linked in a number of ways. Here is an example of how we can use cross-curricular links in a primary setting. Firstly, a class of children could gather a group of insects such as woodlice from the outdoors and create a box with 4 compartments. Once this is done, children can place insects into the box that has 4 different living conditions: wet and light, wet and dark, dry and light, and dry and dark. Children can monitor the woodlice for 4 minutes and investigate where most woodlice ended up at the end of the test. Mathematics could factor in at this point. Children could use bar graphs to present their findings. With interpreting data on the 2014 National Curriculum for both maths and science, this is a simple example of how maths and science can be taught in a cross-curricular way. We have considered the benefits of linking maths and science in a cross-curricular way. At this point, we can ask what impact ICT could have on this form of teaching. ICT can be a powerful tool to enhance children's learning. It can help facilitate cross-curricular links between mathematics and science. There is a range of ICT that can be used in a primary school setting, such as data loggers, sensors, video recorders, interactive whiteboards, digital cameras, and iPads. Lois Kelly stated in her book, Enhancing Primary Science, that ICT could help motivate children, address individual specific needs, and open up a wealth of interactive learning opportunities. Using ICT can allow maths and science to be demonstrated in another way using a realistic and meaningful context. ICT will only be a useful tool in enhancing mathematics and science if it is used in the correct way. For example, children can use data loggers to monitor temperatures around the school. Once temperatures have been taken throughout the school, the data received from the data logger can be presented by a bar graph of results. Once children have created a bar graph of results, they can discuss their findings. This is where the scientific aspect links in. Children can consider the different reasons why the temperature around the school could change throughout the day. If children use ICT and do not understand the context of their learning, answers could be generated without an understanding of the data that has been collected. For example, with the experiment I have previously mentioned of recording temperatures around the school with a data logger, results can be generated automatically when the data logger is plugged into a computer. If the teacher concluded the lesson with showing these results on the board and not discussing what they mean and why, children will not understand the reasoning behind the results. This is an example of where ICT has been used but not understood. So in this case, there has been a misuse of ICT. ICT can be misused frequently in school. Often teachers do not have enough knowledge of ICT to ensure it is used in the correct way, or even to ensure it is benefiting children's learning. Therefore, it is important to state that yes, ICT can be an excellent aid to teaching maths and science in a cross-curricular way, and even for general teaching. However, it should be used when it can provide new learning opportunities to children and enhance children's learning. Cross-curricular links in a primary school setting has been praised by a number of academic writers, as I have previously mentioned. There is a definite recognition that cross-curricular teaching in the classroom can benefit pupil engagement, achievement, and progress. In my opinion, teaching cross-curricular maths and science can be efficient. The links between the two are natural. I feel that teaching maths and science in a cross-curricular way could be a positive way forward to enhance children's learning. However, I feel that it is important to note that there could be cases where links are made between other subjects that are contrived. Some subjects do not link as easily as maths and science, therefore making it essential for all subjects to be taught in a cross-curricular way will not benefit children. Teachers may link subjects for the sake of meeting government standards without considering if the links made are fit for purpose. In this instance, I agree with Lois Kelly and her statement that when cross-curricular teaching is not fit for purpose, then separate subject teaching should be employed and teachers should trust their professional judgment.